So there's one other very important thing with completing the square, and that is that you need to know how to convert quadratics into the form ax plus p squared plus q. This is very useful in A-level, how to convert things into this form, and it comes up time and time again. Before I show you it, there's one thing I need to enhance about the tip. If the coefficient of x squared is not 1, so let's say 2x squared plus 12x, well, let's factor out to make the coefficient of x squared 1. We'll do 2x squared plus 6x. Well, we can use the tip here that we used before. We can rewrite this as x plus 3, because we half 6, squared, and then we minus the square of 3, which is minus 9. However, all of this is going to be in the 2. And this is very important because this minus 9 is going to be affected, because if we expand this, we're going to get 2x plus 3 squared minus 18, because we've taken the minus 9 out of the bracket and times it by the 2. And this is a thing that I forgot so much during my A-level, is that when you're completing the square, when the coefficient of x squared is not 1, you need to times the minus 9, you know, the thing that you minus because of the square produced here, you need to times that by the number here. I forgot that so many times during my A-level, and I hope that you don't do the same here. So let's show how to convert a quadratic into the completed the square form. Let's use the example that we keep using, 3x squared minus 13x minus 10. We won't equal it to 0 as we're just converting it to this form. So the first step is to factor out a, and also factor out a from b. So this might not make so much sense on its own, but you need to factor out a, which remember is the coefficient of x squared, so it would be 3x squared minus, and you need to factor it out from b as well, so you need to divide 13 by 3, so it'd be 13 over 3x, and then the minus the 10. You don't factor out the 3 from the 10, you don't need to. The second step is the traditional completing the square part, about using the tip from before. So we're going to do x minus 13 over 6, because remember we need to divide 13 over 3 by 2, and then we're going to square that, and then we're going to minus the square product of 13 over 6, which is 169 over 36. But remember what I mentioned before about how all of this is going to be in 3, and then the minus 10 will be on the outside. The third tip is to expand the brackets in order to get this 169 over 36 out. So it will be 3x minus 13 over 6 squared, and then you're going to want to times 1 minus 169 over 36, which will be 169 over 12, and then minus 10, and then you can simplify this to do 3x minus 13 over 6 squared minus 289 over 12, and this is in the form ax plus p squared plus q. The pluses and the minuses don't matter, that's not important, that's the important bit. So yeah, that's how you convert a quadratic into this form. This is really important skill in A-level maths, because 1, it's useful for turning points, which I'll explain in a sec. 2, it's useful in chapter 6 when you're creating the equation of a circle, and 3, it's useful in chapter 7 when you're doing some of the proofs. You could also, if you really wanted to, I guess, you could use this to solve quadratic equations by making this equal to 0 and then just making x the subject from here. I would never do this, mainly because the method that I explained before is a much more easy way of doing it. Really quick, the textbook talks about another way that you could do this, where you can do the quadratic ax squared plus bx plus c. You can put it in the completed square form by actually using a formula, which is ax plus 2a under b squared plus bracket c minus b squared over 4a, where this is essentially q and this here is essentially p. Now, if you like formulas and you'd prefer to just sub in the values of a, b and c into this, you can. I would never use this, mainly because I hate remembering formulas, and this is quite a specific formula, and I think it would just add to the amount of stuff that I'd have to remember, and I would much prefer to do it the other way, which is kind of a bit more mathematical and logical. So the fourth and final way that you can solve quadratic equations is by using the quadratic formula. You're not given this in the formula booklet, and to be honest, if you ever do want to solve quadratic equations, again, I'll just use the calculator, I wouldn't use this method. But the quadratic formula is for ax squared plus bx plus c is equal to 0. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So to put this into numbers to make it a bit more easier, because that does look quite confusing, 3x squared minus 13x minus 10, the example that we keep using, x equals minus b, which if we put it in the form up here, will be minus 13 plus or minus the square root of b squared, which is minus 13 squared, minus 4 a, which is 3, c, which is minus 10, over 2, 3. And if you do one of them as plus and one of them as minus, it'll give you two answers, one of them 5 and one of them is minus 2 over 3. Again, though, you might as well use the calculator rather than using this. Really quick, annoyingly, the specification doesn't mention whether you need to specifically prove the quadratic formula or not. Just to be safe, and as it isn't too bad, I'll prove it here quickly, but I wouldn't stress yourself too much over this. All you need to do is complete the square of the traditional quadratic ax squared plus bx plus c equals 0. Firstly, you divide both sides by a to get x squared plus b over ax plus c over a is equal to 0. Then you bring the c over a onto the other side to get x squared plus b over ax is equal to minus c over a. Then you use the traditional completing the square trick by doing x plus b over 2a squared minus b squared over 4a squared, which is equal to minus c over a. Then you bring the minus b squared over 4a squared onto the other side. So you do x plus 2a under b squared is equal to 4a squared under b squared minus c over a. You make the denominators the same by doing b squared over 4a squared minus 4ac over 4a squared, and then you combine the fractions to do b squared minus 4ac over 4a squared. Then you square root both sides to do x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared, which you can simplify to plus or minus the square root of b squared minus 4ac over 2a. And then the final step is to bring the b over 2a onto the other side. So you get x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac over 2a, which you can simplify it to minus b plus or minus the square root of b squared minus 4ac over 2a. And then that's how you get the quadratic formula. Okay, here's a couple of solving quadratic equations questions to have a go at. So have a go, pause the video, and then I'll go through the answers in about 5 seconds. Okay, so the first question doesn't want you to solve the equation, it just wants you to put it in the completing the square form. So the first thing you need to do is factor out the 2. Let's do 2x squared plus 4x, because 8 divided by 2 is 4, and then the plus 3 remains on the outside. And then you do the technique. So you do x plus 2 squared, because obviously 2 is half of 4. And then you minus the 4, because 2 squared is 4, and you need to cancel that out. And then you put that all in the brackets of 2, and then you plus 3. And then you expand the brackets to do 2x plus 2 squared minus 8 plus 3. And you simplify that to do 2x plus 2 squared minus 5. And that's the final answer. As I always say, a tip that you can do if you want to compare your answer to, if you want to know that these two are the same and therefore you've got the correct answer, is you can sub in a value for x for both, the same value of x, and if it gives you the same output, then you know that they're equivalent, and with some confidence you can say you've got the right answer. Okay, so for number 2, this is literally just ridiculously easy. I would just put the values in the calculator, as I've explained before of how to do, and you will find the answers are 9 plus root 65 over 2 and 9 minus root 65 over 2.